All right, guys, hello and welcome to another physics lecture. Today we are going to be talking about graphs, specifically acceleration graphs. All right, so the first thing that we need to do is review what acceleration is. All right, acceleration is a change in your velocity or an object's velocity. Velocity, if you remember, is speed with a direction. So all velocity is a speed that can be positive or negative, okay? Now, acceleration is measured in meters per second squared, okay? We'll come back to this on the next slide. The thing that you gotta remember is that velocity can be a change in speed, because velocity is speed, or a change in direction, because velocity has direction, okay? Again, we're gonna talk about this a lot more when we get to forces, all right? But a big thing to remember is that velocity is speed with the direction. Acceleration is a change in velocity. So that means it can be a change in your speed, going faster or slower, or a change in your direction, meaning when you turn, all right? So, differences between acceleration and velocity. Velocity is speed with direction. Acceleration is when you change your velocity. And the big giveaway here, whenever you see them in an equation, is that velocity is always going to be in meters per second and acceleration is always going to be in meters per second squared, okay? Always check the units to know which one you're dealing with. They look really similar, but they are not the same at all, okay? Velocity is how fast you're going, and acceleration is a change in that, okay? Or velocity is the direction you're going, and acceleration is a change in that. Okay, so things that you need to remember for today, the three big graph things, okay, is that when you have a distance graph, the slope of a distance graph is your velocity, okay? We learned that. That was like week 1. Week 2, we learned that the area under a velocity graph is your distance. Remember, this is the one where we found the rectangles and the triangles. If you don't remember how to find this, go back to my video called Area Under the Curve, and I go over all of that in detail. If you don't remember how to find slope, go back to my slope video, and I go over all of that in detail. Now, today, we're going to learn the following. If acceleration is a change in velocity, then the slope of a velocity graph is acceleration, okay? So, in order to go through this, what I'm going to do is I'm going to go through 7 examples of 7 different instances of how an object can be moving. And I'm going to show you what the distance graph looks like, what the velocity graph looks like, and what the acceleration graph looks like, okay? This can be tricky, so I'm going to try to show you the best way to read through these, how to check them. And the first thing you got to remember are these two, actually. We don't need this one for today. The slope of a distance graph is velocity, and the slope of a velocity graph is acceleration, okay? If you can write these down, make sure you have them, okay, because they're going to be really important as we go through these examples. As we go through the examples, draw the basic graphs, okay, and draw these curves with me, and write down any notes that I write down, okay? I promise if you do that, this will all make sense. All right, so let's get going. All right, first one's easy. Somebody standing still. Okay, if you are standing still, that means your distance is not changing, right? You're not moving forwards or backwards. So here we have a distance graph. It's a distance graph because distance is on the y-axis. Distance is measured in meters, right? So if you're not moving, okay, that means your distance is staying the same. So it could be, you could be in front of the starting position, you could be behind, you could be right at the starting position, or you could be below the starting position. Doesn't matter, okay? The thing is, if you're standing still, your distance is not going up or down. It's flat. Now watch how we do this. The slope of a distance graph is velocity. This is a velocity graph. Velocity is on the y-axis, measured in meters per second. Well, the slope of this line, and this line are all 0. It doesn't matter what the instance is, your velocity is going to be constantly 0. You see that? Right on the 0 line, okay? And here's the next jump. The slope of a velocity graph is acceleration, okay? The slope of this graph is equal to acceleration, right? So let's look at this. What's the slope of this line? Well, it's flat. If it's flat, that means my slope is 0, all right? And this makes sense. If I'm not moving, my distance does not change. If I'm not moving, that means my velocity is 0. And if my velocity is 0, it's not changing, so my acceleration is 0. Boom, boom, boom. So again, as we go through these, remember, it goes distance, velocity, acceleration. The units get bigger and more complicated this way, and the slope of this graph is equal to this graph, and the slope of this graph is equal to the line in this graph. All right, let me grab my eraser. All right, so this is number 1. Okay. Draw 3 new graphs. And when you draw these, I would recommend the first one, labeling them just like I label them. But from here on out, when you draw the graph, literally draw 3 graphs like this and go D, T, V, T, A, T. Okay? And write down the situation here. I know it's some writing, but trust me, these are the notes for today, and this will make it so much easier. You will get a 100 on the DOL if you go through this, I promise. Okay, show someone moving at a constant velocity in a positive direction. Okay, so here's what we got to remember. On a distance graph, a positive direction means the line is going up. Okay, so I know my line is going to go up. All right, if my velocity is constant, that means that line is going to be flat. I'm going to switch colors. This red's a little more bold. I'm going to use this red. So here is a constant velocity in the positive direction. Again, I know it's positive because my slope or my line is going up. That means I'm moving forward. And I know this is a constant velocity because the slope is the same everywhere on the line. Ready? Next move. Let's make our velocity graph. The slope of a velocity or a distance graph is velocity. Well, the slope of this line, is it positive, negative, or 0? It's a positive, which means I have a constant positive velocity. My velocity is constant because it's flat, it's not changing, okay? And it's positive because it's above 0. Remember this line, all these lines here, this is where 0 is. You need to mark that to be helpful. Remember that. Okay? Last trick, the slope of a velocity graph is acceleration, right? Acceleration is a change in velocity. Is my velocity changing? No. It's a constant velocity, right? Well, what's the slope of this line? It's 0. What's my acceleration? 0. Nada. Right? Okay? First 2, pretty easy. We haven't really even gotten into acceleration graphs yet. Okay? You just got to understand what you're looking at, understand what you're reading. Number 3. Okay, someone moving at a constant velocity in a negative direction. All right? Let's go through this again. I have a constant velocity, which means my distance graph is going to be a straight line, but I'm moving in a negative direction. So again, negative means you're moving down, right? So this is a constant velocity in the negative direction. Okay, the line's going down. It can keep going down, that's fine. It could go below 0, that is still constant velocity in a negative direction. Our distance is moving backwards, our velocity is negative. Now, the slope of this line, the slope of a distance graph equals velocity, all right? Well, is the slope of this line positive, negative, or 0? Well, it's going down. We know the slope of this line is negative, right? Which means that the velocity of this line is going to be negative. It's going to be below 0, okay? And I know that this line here is going to be flat because I have a constant velocity, so it'll look like this. Okay. I tried to find some better graphs here. Extend that down, all right? Okay. Here is exactly what this is telling me. I'm moving backwards. Velocity is either positive, moving forwards, or backwards, moving negative, meaning it's moving backwards. we're moving backwards, so my velocity is zero, or is negative, and my velocity is constant, which means it's not going up or down, it's staying the same, okay? And then the slope of a velocity graph is acceleration. Well, what's the slope of this line? It's zero, right? And acceleration is defined as a change in velocity. Is my velocity changing? Nope, it's constant. So my acceleration is still zero. See that? Right? These first three, pretty straightforward. They make a lot of sense. The big thing to remember here, okay? On a distance graph, if the line goes up, we're moving forward. If it goes down, we're moving backwards. Okay? The slope of a distance graph is velocity, literally y divided by x, which is meters divided by seconds, meters divided by seconds. The slope of a velocity graph is acceleration, right? Y divided by x. Meters per second divided by seconds gives me meters per second squared, right? Aren't graphs cool? All right, let's look at the next one. All right, we're gonna go to a medium dog problem, okay? Show someone moving at an increasing velocity in a positive direction. All right, okay. So now from here on out, we're gonna have two things to look at on our distance graph, which we've been looking at, I just haven't pointed them out. We care about which direction we're going and if it's increasing or decreasing, okay? So before, when we had a constant velocity, our lines were straight, okay? Either straight, positive, zero, or moving backwards and negative. Now, we have an increasing velocity. What that means is our slope isn't gonna stay the same. Our slope is gonna be changing, all right? So remember, a flat distance, this slope is zero, okay? As it gets steeper and steeper and steeper, it's going faster, 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 okay? Going slower, lower slope, and then as it decreases this way, we're getting more slope, more slope, more slope, more slope, okay? The steeper the line, the bigger the slope. So let's see what that means. The first thing we have is we know we're moving in a positive direction, which we know our line is going to be going up. That's useful. Number one, we're going up. The second thing that we see is we're moving at an increasing velocity. And what that means is that our slope has to increase. What does that mean? Well, that means our slope is going to start really flat, and as our line goes up, our slope is going to get steeper and steeper and steeper. Everybody see that? We started with a small slope, it's very flat, and as the line moves forward, it's going to get steeper and steeper and steeper. Well, what does that look like as a line? Well, it looks like this. It's a curve, right? This is what an increasing or velocity in the positive direction looks like. I know that it's in the positive direction because our line is going up, and we have an increasing velocity, which means my slope, look at this, I put my ruler on the slope. This is my trick for you. You can use your pencil, take your pencil, okay, look at the distance graph, look what the line does. Follow it with your ruler or your pencil. Look at that. Does everybody see? The slope increases. It gets steeper and steeper as the line goes up. That means I have an increasing velocity. It's a cool trick, right? So now, our velocity graph. The slope of a distance graph is velocity. Can you find the slope of this line? No, because...
Staff members, good morning.
Sorry, guys.
This is just a reminder that you need to report to your duty assignments at this time. Again, all those that are assigned to Bo Bison.
I'm
if
aware
you would please report
this
at
is
this
not
time. Also, those that are assigned in the front, please report to your duty sites at this time. Thank you very much.
Sorry,
Have a great
guys.
day.
I can't control the announcements. My apologies. Okay, so we have an increasing velocity. So what does that mean? The slope of this line is constantly changing, and that slope is getting bigger and bigger and bigger, which means my velocity is going to be increasing. My velocity is getting bigger and bigger and bigger. I have an increasing velocity, okay? Why is the line going up? The line's going up because I'm moving in a positive direction. So I have a positively increasing velocity. Nice. Last trick, the slope of a velocity graph is acceleration. This one's easy. Is this line right here positive, negative, or zero? Well, the slope is going up. so it's positive. So I have a positive acceleration. Nice, right? Okay. And we're going to take this example and do it 3 more times so you can see all the permutations. Somebody moving at a decreasing velocity in a positive direction. Okay, so we got 2 things again. We're moving in a positive direction, so my distance is going to go up. But now I have a decreasing velocity. And what that means is that my slope, instead of getting steeper, is going to start really steep and get flat. Oh, look at that line. So instead of curving up, it's going to curve like that. Okay? Okay. So let's look at it. Make sure we got it all. We're moving in a positive direction. We're going up. Okay? Check. And our velocity is decreasing. That means our slope is decreasing. Well, look at the starting slope. We started super steep, and as the line moves forward, the slope gets flatter and flatter and flatter. That's a decreasing velocity. All right. Here on our velocity graph, we're in the positive direction, which means we're going to be on the positive side of the graph, right? We're going to be above 0, okay? And our velocity is decreasing, meaning we're going from, 100 miles an hour to 0. So we start off fast, and we get down to slow, right? We started with a steep velocity, which is really fast, and our velocity goes flatter, flatter, flatter. Our velocity starts off positive and high and goes down, 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 down until it gets to 0, right? Last step, the slope of a velocity graph is acceleration. Well, the slope of this line, it's flat, good. Is it positive, negative, or 0? And obviously, the slope of this line is negative. So here is what my acceleration graph is going to look like. And again, I got to extend this. You can extend yours too. There you go. It's negative. It is below 0, but it's flat. Why is it flat? Because this line is flat. It's straight, right? It's a straight line, which means I have one slope, which means I have one acceleration. Everybody see that? Graphs, aren't they cool? All right. Let's do 2 more. These last 2, these are what I call the big dog problems. All right. Someone moving at an increasing velocity in a negative direction. Okay. So here we go. So if we're moving at in a negative direction, that means our line is going to go down. Okay? Because we're going backwards now on our distance graph. Remember, on the distance graph, up is positive direction, down is negative direction. So our line is going to go downwards, all right? And we're moving at an increasing velocity. So that means that our slope is going to get bigger. So the line's got to go down, and our slope has to go from flat to steep. Look at this. Flat slope, slow, faster, 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 faster. And the line's going down. Here, negative direction, moving down, and our slope of this line is constantly getting bigger. Look at that. That's a flat slope. Follow the curve. Look at that. You see how the slope gets bigger and bigger and bigger? That's why we have an increasing velocity. Bam. All right. Let's look at the next graph. Let's look at our velocity graph. Okay. So same thing. 2 questions. We have a negative direction, which means we're not going to be in the positive part of the graph. We're going to be in the negative part of our velocity graph because it's a negative direction, which means we're down here. And I have an increasing velocity. What does that mean? Well, if I have an increasing velocity, that means that our velocity is speeding up, right? We're going faster. And when you go faster, that means your velocity moves away from 0. Makes sense? We talked about this before. This is an increasing velocity in a negative direction. Again, how do I know we're moving in the negative direction? How do I know we're moving backwards? Well, because anytime your velocity is negative, you're moving backwards. If your velocity is positive, you're moving forwards, right? Remember, positive is just direction. Positive is forward, negative is backwards. And this line right here starts at 0 meters per second or 0 miles per hour and goes bigger and bigger and bigger in a negative direction, okay? So the last one that we got to do here is we have to find out what our acceleration is. So again, here, the slope of this line, is it positive, negative, or zero? The slope of the line is negative, so that means that our acceleration, okay, is negative, right? The slope of this line equals your acceleration, right? And then the last one, someone moving at a decreasing velocity in the negative direction. This is the trickiest of all of them. All right, we're moving at a negative direction, which means our line is going to go down, and we're moving at a decreasing velocity, which means that our slope is going to start off really steep and end up really flat. So this, last but not least, this is moving in a negative direction because our distance is going backwards, and this is moving at a decreasing velocity because the slope of this line is getting flatter and flatter and flatter and flatter. Move over to our velocity graph. Again, we're in the negative direction zone. So we're going to be in the negative part of the velocity graph, okay? And I have a decreasing velocity, right? So what that means is that my velocity is going to be decreasing down here in the negative area. And when I decrease my velocity, I go towards zero, right? We're in the negative. I started off, let's say I'm going backwards at 100 miles an hour, and I'm slowing down, negative 40, negative 30, negative 20, boom, back to zero, okay? Decreasing my velocity, going towards zero in the negative area. Last but not least, acceleration. Again, you can overthink this and say, there's rules to this. Here's how I do it. Is the slope of this line positive, negative, or zero? Because the slope of a velocity graph is acceleration. This line's going up. This is positive, which means my acceleration, ba-boom, is positive. Okay? Again, make sure for each of these examples, take a second, write down the example, draw 3 graphs, just label them D, T, V, T, A, T. Draw the lines and whatever notes that I gave you that help. If you want to write down that, distances going up, okay, positive distance is moving forward, that's up. Moving backwards, your distance is going down, okay? An increasing slope, okay, when the slope gets steeper, it's increasing, right? So this slope is decreasing, it's getting flatter, okay? Velocity, as it goes away from zero, it gets faster. As it goes towards zero, it gets slower. If that happens above zero, it's positive, it's going forwards. If that happens below zero, it's negative, going backwards. And your acceleration is just the slope of your velocity graph. Armed with all this, you guys can crush the DOL, okay? Copy down the graphs, take the notes, do awesome. All right.